Like for
No, yeah, no issues.
okay, cool, cool, sure. So great. So I'll begin. Okay.
Yeah,
So
cool.
first of all, I would like to begin this session by thanking you for coming here and helping out our juniors. So yeah, let's go. The first thing that I want to ask you is that please give us a short introduction about yourself, what you have done, and
All.
please don't be humble at all. People
Yeah,
listening.
sure.
Hmm,
So, guys, I'm Ashutosh Pandey. I'm a compiler engineer at AMD. I work on compilers, and before this, to get here, I've done Google Summer of Code with Arduino in 2020, which is where I got to know Rahul. And other than that, I've done mentorship under the Linux Foundation, and I've also worked with the FSF and GNU. I'm also one of the winners of Smart India Hackathon 2019. So that's some of the stuff I've done. Other than that, I worked with the team that created Raspberry Pi 4B. I'm one of the beta testers of the board. And what's important here is I work on embedded systems, hardware, and low-level programming, including compilers. So yeah, that's an introduction.
great. You mentioned a few acronyms such as FSF and GNE. Just elaborate on that. Can you?
Yeah, sure. So the Free Software Foundation is like basically the body that protect. If you've ever done open source, you might have heard the term license, and you know how licenses are very important to protecting the rights of open source software. So I was an intern at FSF for one of the GNU projects. It was about hacking into an Amazon Kindle and trying to replace the firmware with free software. So yeah, that kind of stuff.
Great, great, great. Wow. So that was quite a particularly heavy introduction. And now, if we move on to the next question, I would like to ask you that you said that you are a compiler engineer at AMD, right?
Yeah.
So, what does a compiler engineer actually do? And in a follow-up question would be that how is it different from the normal software engineering jobs that we see in the market?
All right. So this is a very good question, because many people have asked me, like, compilers already exist, right? What is the so what do you exactly do? Like, I just
Yeah,
put my code, like, everyone uses a compiler and sort of takes it for granted. Like, you're doing, say, competitive programming. You invoke one command to run GCC, it compiles your code and gives output.
yeah,
That's it. But obviously, the answer to that is stuff like, Google search already exists, right? So what do the engineers do? So we improve compilers. Basically, if you think about it, every time AMD comes out with a new processor or Intel comes out with a new processor, the processor itself is just a hunk of silicon, right? It can't do anything on its own. When you add a feature to the processor, somebody's got to write the code to take advantage of those features. So a lot of the optimizations and speed ups that you see, like this generation's Ryzen is 20% faster than the last one. Those come from compilers taking advantage of the hardware. And basically, in our line of work, like when I work, we see that, like, we see the compiler through a very different lens. It doesn't seem like a perfect piece of software that just compiles your code. Like just last week, my team found an optimization that cut the compile time of one AI weather modeling application from like 8 hours to 3 hours. So
oh, great.
there's a lot of scope for improvement in compilers. So basically, it's like along 3 4 lines. One is you're obviously working on making it faster. Like you're working on making the compiler faster and faster, finding more efficient way to do things. Other than that, there are a lot of things. Actually, a lot of other tools that developers use are also written using compilers. Like if you ever used VS Code, you might
Mhm.
have used VS Code autocomplete, or IntelliSense as it's called. So that is
Correct.
also written using a compiler. In addition to that, tools like linters, debuggers, all of them are also written using compilers. In
Yeah.
addition to this, there's a lot of research these days in into programming languages that can operate at a higher and higher level, where you need to specify lesser and lesser things, and the programming language makes assumptions for you. So, it's a very exciting field. We interact regularly with folks from Facebook, ARM, NVIDIA, and yes, even Intel in collaboration, because most of the tools are open source. So you need to
Correct.
collaborate to survive. And to answer your second question, how different is it from a normal SDE job? So again, it's in some ways it's very similar. In some ways, it's very different. So
Got
it's similar in the sense that like just like any SDE job, you gotta know your programming languages well. You gotta know your tools well, and indeed, compiler engineers can easily switch between fields. There are a lot of people in my team who are game developers before, or C++ programmers at other FANG companies. But it's very different in the sense that the focus is not on banging out tons of code. It's more important to be correct than to be fast. Like most
oh,
of the most of the programmers in my team don't write like more than 30, 40 lines of code a day. Whatever you write, it has to be correct, because if you break the compiler, then nothing else in the computer is going to run. So that's the gist of it.
perfect. Okay, that was pretty insightful. Thank you. Like nobody had ever explained it to me like that. Okay, so since I have been working with computers, but it is mostly the software, I too don't have any idea about embedded systems or anything like that. So
Yeah.
I'm going to ask a question. It may be a foolish question. It may be a good question. I don't. So I want to ask you that what is the difference, if there is any difference at all, between embedded programming, IoT programming, and hardware hacking or hardware programming? Is there any
Uh,
difference?
I mean, a lot of them are related. Like, the biggest difference between, like, if you ask any old person, what's the difference between embedded programming and IoT? So it's basically embedded systems plus networking. Like in the past, you had microcontrollers that did a lot of stuff. Even
Yeah,
today, say you take a normal car, you're turning the steering wheel a little and the car turns. That's power steering and stuff like the brake system, the airbag system. All of these rely on small micro controllers that do a lot of different things. An average car has like 60, 70 microcontrollers, and that's just one example. So microcontroller developers typically, they rely on closed systems. Like the microcontroller has to do one thing in a loop with no interaction from the outside world. So but IoT, it just adds a like a network to this system. And now since you have access to a network, you can do a whole lot of stuff. You can connect to the internet. You can take advantage of AI ML. Like you can probably offload all the data you collect to some server somewhere that does some data processing, and you can make inferences, like say something like Amazon Alexa. So that uses a microcontroller just to recognize the wake word, which is "Hey Alexa," and after that, the device has to listen to your voice, apply processing to recognize what you're saying, and then extract meaning from that. So IoT is just a combination of networking concepts and hardware. And obviously hardware hacking is slightly different. Hardware hacking is more about taking existing devices and making them do your bidding. Like say you have an electric blender in your house, but you don't want to press the buttons on the blender. For some reason you want to control it with your mobile phone. So you got to open up the device, maybe add a control mechanism to it, break into its firmware, find out how it works, and then add your functionality. So hardware hacking is all about taking everyday objects and modifying them so that you can get what you want out of it. That's the difference in brief.
okay. That was pretty cool. I understood quite a bit. And I would request everyone from the audience, especially the first and second years, like if you are listening to this, please have a pen and a paper ready. and take notes. Whatever you find interesting, note that down. हम लोग सत्संग में तो बैठे नहीं हैं. And you won't catch hold of this guy pretty easily. So just take notes. Okay. So let's move on to the next question that I have for you. So you told me what you do as a compiler engineer. You told me what is the difference between all the fields that I had confusions about. Now
Yeah.
I want to ask you, how do you how do you think embedded programming is different from traditional programming, like say competitive programming?
Yes, so this is a very good question. One thing I'd say is embedded programming is something about being a whole lot more careful than traditional programming. Like, because of the powerful features that languages offer these days, you never particularly think before you declare, say, an int data type in a program rather than using a long or declaring an array of indefinite length, or worrying about things like memory or processing power. But say the older AVR microcontrollers that we had back in the day, like Arduino is the most popular example. You have 32 kilobytes of memory. you have you have it running at 16 megahertz, and that's a very big microcontroller. There are microcontrollers like 80 tiny, where you have 512 bytes of RAM, and you have to fit everything to run in that. So
Okay.
obviously, like, one thing about embedded programming is you have to be a lot more careful about how much memory you're using and whether the device can do what you want it to do. And secondly, you have to make the system really, really secure because of the places where embedded systems are used. We have this concept of something called an RTOS, a real-time operating system. So, say you're flying a drone. In a drone, I used to work in a team that used to build drones before. So, you have a drone and it's flying in the sky. You give a command, the drone has to respond to that command within a set specific time. It's not like your computer. Like, your computer can afford to hang for 2 seconds, but say if you're in an airplane or you're in a drone or you're in a rocket, if the system doesn't respond within that fixed time period, it can mean the destruction of the whole system. So you have to
Yeah.
program within those parameters, like those edge cases, like unexpected inputs and all that. You have to account for all that and make sure that under no circumstance should you get an unexpected output like for any kind of this thing. In addition to that, like, in a way, I think embedded systems is a lot more interesting than like, at least for beginners, than real world programming. I'll just take a small tangent here. Like, when I started in college, I was not particularly fond of programming. Like, obviously, just like anything else, right? It felt like, yeah, you're typing something on the screen and something else is showing up, blah blah. Like, okay, why should I be excited? Because it takes a long time, to get to the point where you can actually do cool stuff with programs. For a lot of time, you're left fiddling with loops, arrays, and printing out patterns, and doing searching and sorting and all that stuff. But in the second year, I was in a team that used to build drones, and they were like, we have a problem. Like, our team's poor. Like, Indian teams always have a shortage of funding to buy
Yeah. Yeah.
to buy anything. So we had to participate in this aero design competition in the US, and our plane could only carry so much weight. And the automated tracking system that was there in the market was too heavy for our plane. So they were
Okay.
like, dude, build a system that can relay data from the airplane to the ground. And then I began realizing slowly that when the stuff you program crosses into the real world, like,
Yeah.
even something as simple as blinking an LED or making a buzzer work, or taking data from a sensor and responding, when it starts like interacting with the real world, you just begin realizing that how cool programming really is. So in
Definitely.
that ways, it's a lot more fun to do. That's what I'd say.
That is awesome. And one thing I actually used to wonder, actually, I saw pretty like many memes on that. that
Yeah.
the Apollo mission program for the moon, the code for that was written in 128 MB or something like that, and
Yeah.
the programmers today have 12 GBs of RAM on their laptop and they're still crying and stuff like that. So that is what intrigued me, and like you know it offered an insight into what actually these guys do, like writing
Yeah.
code that is so close to the hardware.
Yeah,
So,
exactly.
okay, I think that in our audience there is there are a number of first years and second year students, so they might not have much of an idea about the actual functioning. So here's an LE5 question for you, explain like I'm five question.
Yeah.
So it's maybe it's gonna be a bit long, so you can oversimplify it if you want. It's not an issue.
Yeah.
So the question is, every one of us have an idea, like at least an idea about at least how Java code is run on computers. Okay,
Yeah.
we open an IDE, we write some code, and the JVM then converts it to bytecode, and the bytecode is executed by the compiler installed in the laptop itself. Okay,
Yeah.
so that is what happens when you run Java code.
Yeah.
Now tell me, how does a piece of code run directly on a hardware when you program a chip? I mean, is is there a difference, and like how does it run directly on a chip? I mean, there is no
Yeah.
compiler.
Yeah, obviously. Yeah, that's a good question. So, like normally when we compile a program on a PC, like a lot is going behind the scenes. Like modern day compilers, especially the C++ compilers and all that you'll see, they do some really interesting stuff. Like, first of all, the compiler has to take in the keywords that you type, separate it into like keywords. Like, say you write a for loop, it has to
Yeah,
recognize the first keyword for, then an open bracket, then the integer I, then an equal to sign. Then it has to group them into meaningful groups, where one statement is ending and the other is beginning. Then you got to make an order, like inside this for loop I have this statement, inside that statement I have another statement. It's got to construct a tree, which we call a syntax tree. Then you generate code, and then you finally translate that intermediate representation or whatever you have into your final machine code. So the modern day compilers like LLVM and all that, it's more like it's a set of libraries that when ordered in, put in a particular order, they build a compiler. So it's like very modular, and that allows you to do things like cross compiling. And this is what is done for microcontrollers. Basically what you do is you use your existing machine, which say is running on an Intel chip or an AMD chip x86 architecture, and you are compiling for that target device, which may be running on some other architecture. Like most microcontrollers run chips based on ARM or AVR. So that's a whole different architecture, right? But the compiler is able to take code that you've written on one platform, write outputted code for another platform. And like if you take AVR microcontrollers, you can actually see this. It converts the whole program into a string of hexadecimal numbers, and only that final output is loaded onto the board. So it's like basically your computer did all the compiling, and it just gave the board the final compiled code that tells, like switch on these registers, switch on these transistors, switch on this LED, do this, do that. And the microcontroller just keeps running the same program in a loop. So that's how it's happening. It's a technique known as cross compiling. So
okay,
yeah.
okay,
Yeah.
got it. So I too am taking notes. I will go on a further study it. These are interesting things, man. Like
Yeah, like one interesting application of this is Apple's new chip, M1.
M1. Okay.
Yeah, so like when Apple came out with M1, everyone was like, "Damn, dude, I'll have to rewrite all my applications for M1 again." Because they switched architectures, they switched from Intel to an ARM based chip, and everyone was like, okay, now everyone will have to rewrite their programs. Nothing will run on M1 anymore. Just like how Windows keeps trying to, like Microsoft keeps trying to release a Surface that runs ARM, and it never takes off because they can't get their programs to run on their own tablet. But that didn't
Correct.
happen. That's because Apple did some really clever stuff behind the scenes. They combined the instruction set of x86 with ARM into one common design, and they wrote an emulator, basically a kind of a compiler that can take one kind of code and transform it into another kind of code, and they do it so efficiently that you can even play games on on an M1 Mac. And M1 Macs run Windows better than Microsoft's own tablets run Windows.
Oh,
So
damn.
so
Okay.
so that gives some idea of the kind of clever stuff that people do behind the scenes.
Yeah, that is actually what is pretty interesting to me. The kind of drastic changes you can do using compiler programming. That is what has been interesting me for a long, long time.
Yeah,
So, okay, yeah. So you mentioned in your introduction that you won the SIH hackathon in the hardware section, right?
yeah.
And also, if I know like you much more than that, you have also won several different hackathons apart from SIH.
Yes.
Around
So
five.
yeah, around five of them.
Okay.
I've been doing a lot
So
of stuff in
yeah.
college. Yeah.
So the question for me and for you and like something that I want everyone to know is that what is the secret? What is the secret recipe of winning hardware hackathons?
Yes. All I'd say is, like most of the one thing that I'd say is, most people when they start out at a hackathon, they're like, dude, this sounds cool. Let's build this. And, the thought process stops there. The thing is, with hackathons, you have to like be like a lot of people are like, let's just use the latest technology, build something cool, and try to do it. And they think that hackathons are totally random events where the judges choose whoever they want. But the fact that people who do well at hackathons, generally they do well at a lot of hackathons, so obviously there's something that
Yes,
they're doing right. it's
correct,
not
correct.
it's not completely random. So how it works is, I begin by taking a problem statement. Like I'll say, like there was one competition by Dassault Systems, the guys who build Rafale and all that.
Yeah, yeah,
So
yeah.
me and my friend qualified for the final and finished like in top three in the whole country in that.
Very
So
nice.
the thing we thought was, prosthetics. We started with an idea of prosthetics. We saw that prosthetic legs were really common in the market. They're very cheap also. Like for say a few $1,000 you can get a prosthetic leg. It won't be perfect, but it's gonna be good enough for a disabled person to get about their life if they have one leg. But prosthetic hands, on the other hand, because our hands are much more complicated than our feet. They have to not only support your weight, you got to move your fingers, you have to hold things, you have to grasp things, you have to bend your arm. So that was a whole lot costlier. It was very expensive, and they ran into lakhs and lakhs of rupees. So me and my friend thought that let's build a prosthetic arm, a whole prosthetic arm, including 3D printing. And if you know some designing and some hardware, that's the coolest part, right? You're like Iron Man. You can think of an idea and you can build it. It's like a
Yeah.
superpower. So overnight, over like the next few months, we came up with a design of a prosthetic hand that would require only one servo to function, using a mechanism that connects to the top of your arm, reads the signals from your muscles. Like every time you flex your muscles, electrical signals are generated inside your arm, and there are sensors that can
Oh,
pick that up. So we took those signals, processed that data, and it was like you can move your fingers without having fingers. So that was the idea we demoed. So, and again, it didn't stop there, right? We had to do market research. we went to Google Scholar, we found papers, and we were like, this is a $300 million market right here in India. These many people suffer from accidents every year. These are the injuries they kind of suffer, and this is the amount of cost undercutting we can do. So in general, if you're taking part in a hackathon, you can think of like two, three rules, right? Either make something that's the first of its kind.
Hmm.
If that is not possible, either make something that's cheaper by a significant margin, or build something that's faster and better. If you're able to hit two of these 3 points, right, you'll have a winning idea on your hands. So either make it cheaper, or make it faster or better, or make it totally unique, so that you have your selling point. And when you pitch, you're not pitching to technical people. Most of the time, the judges are like people like CEOs and managers of companies, or really old people who've been out of the tech scene for a lot of time. You have to accurately gauge what level of technicality you want. Talk about the features of your product, sell it like a salesman, not like an engineer. So if
Hmm.
that makes sense. So
Yeah,
when
yeah,
you
that.
start yeah, so that, like, how you pitch your slides or how you give your demos. Because a lot of people are hung up on making the thing work rather than making it proper. Now you have a lot of prototyping tools. Like, say you're in a hackathon, there are tools like Adobe XD that let you prototype a whole app within a few minutes. Like,
Hmm.
the app won't be functional, you'll have only dummy screens, but it
Yeah.
will accurately represent how your final application is going to look like. So say you design something like that in the first few hours of the hackathon, go to the judges, get feedback. Like, often hackathons have these desks where you can ask people for feedback right in the beginning. So if you
Okay.
take feedback in the beginning, take their inputs, combine their inputs with your ideas, iterate multiple times, you will come up with a winning idea. Especially for hackathons like, Smart India Hackathon, which the hardware edition takes over 120 hours non-stop. So that's 5 full days of people building day in and day out. Like, people just bring those what do you call it, blankets, and they sleep right on the floor next to the the bill, like the table where the hacking is going on, because they don't want to miss out on the chance to build. And a lot of people implement stuff that can't be shown to the judges. I'll give you a funny example. We were in SIH, right? And there was this judge, and on the fifth day, like, one team from, I think it was from IIT BHU, I think, they demoed a shirt which can detect heart attacks. All right. And how it would work is just like Iron Man's suit. It had a giant red LED ring type of thing, and if you get a heart attack, it will start glowing red. So the judge pointed out that, if I'm getting a heart attack, I'm not sure if flashing red lights is the first thing I want to see. And secondly, then the judge was like, let me try out your application. So he wears the shirt, okay, and he's like, nothing is happening. And then the team is like, sir, you gotta get a heart attack for it to work. so so you can obviously see the problem with that, right?
Yes,
Like,
yes,
they
yes.
implemented a feature that nobody can test.
Correct.
or or even how you answer judges questions. Like, there's another team that built some solar cooker with an integrated Wi-Fi panel. So judges are like they'll pick a weak point and they'll start, right, to see how you answer. So judges like, aren't solar cookers really slow? And
Hmm.
then the team leader is just like, so what should I do? And the judge is just like and the judge is just staring. So, small things about how to talk to people, how to convince people of your idea, where to hold your ground. Like, what we built for Smart India Hackathon was, we went, saw Avengers Infinity War just before the hackathon, got really inspired. We were like, let's build a gauntlet like Thanos. And so we were like, let's build an exercise tracker that can track any exercise. Like, let's say there's a javelin throw athlete, so they can throw the javelin like 10 times, and the device will record those and then tell you how accurately you're throwing the javelin based on data, and count the number of times you've thrown that, or say dumbbell curls or stuff like that. So we made it really big and heavy, like it was. And the judge was like, sure, you got a screen on your device, but is the screen really necessary? Can't you just send the data to a phone or something? We were like,
Mm.
sure. It was difficult, because this was the third day of the hackathon and they were asking us to change our whole design. So
Correct.
that cut down our weight from like some 250 grams to 20 grams, and we made this small hockey puck size thing, crammed everything into that. So
Yeah,
you got to know what,
that also
yeah.
makes sense because if I'm throwing a javelin, I would want minimum weight on my arm, right?
Yeah, exactly. But again, some of the other advice that they gave was not so good. So you have to weigh in, like you can't completely give in, because if you're not able to justify any of your decisions, then you're losing. So you got to strike a balance between taking their inputs and sticking to your vision of what you want to build. So
Correct,
I think,
correct.
yeah, that's a brief idea of how these things work.
No, first of all, that was not brief, and second, it was really, really insightful and profound. Because I too had gone to several hackathons and I failed in all of them, almost all of them. And I realized that the people that were doing good in hackathons, they did not do good in just one hackathon. They
Yeah.
kept on winning and winning and winning, and I was like, "Ye hota kya hai ye?" So
Yeah.
now I'm getting the feel for it. And also I think that hackathons should be a must for must experience for the students, because hackathons teaches you to talk to people. It teaches you to sell something. Okay.
Yeah.
And even if you are not selling something in your later life, I'll give you an example of what just happened. Okay, so I got a job just very recently about the last Sunday. Okay, so the
Mm.
job offer was for suppose say a decent amount, but I called the manager again and I said that I want to talk further. So this talk was for negotiations. Okay, and he wanted to know very bluntly that why do I think that I deserve more salary. So if I was not confident, if I did not know how to talk to people, if I did not know how to sell my skills, I would not have made the call and I would not have got the 2 lakh increment that I got. So yeah, the base increased 2 lakhs, the overall CTC perks increased and stuff like that. So
Okay.
the thing is that
Congratulations, man. You didn't tell me you got a job. Anyway, yeah, congratulations.
it's a blockchain smart contract job, but it's a good thing.
It's
Anyway,
a good
so
thing. Yeah.
yeah. So the thing is that you should know how to talk to people. Just because you are an engineer, that should not mean that you should bury your head in code and laptops and not talk to
Yeah,
people.
dude. I mean, if you had to summarize it in a line, the difference between you and other engineers is what people do when you're not coding. Like, I mean, everybody codes, right? What happens
Correct.
when you're not coding? So that makes a very big difference. Uh, like, whether it's putting your hands in marketing or thinking about the ethical implications of what you're doing, why you code, why you build stuff. So all of those things are really important. So yeah.
Yeah, like definitely. And the part where you mentioned that there are tests for taking feedbacks in the hackathons, I did not know that.
Yeah.
And I truly want the people that are listening to take notes, to literally take notes with a pen. I'm sitting with a pen, if you can see, beside Hashirama, and I'm taking notes. So please do take notes. Okay. Now let's move on to the next question. Assuming that people are really interested in what you have said and they want to start off with embedded programming, they at least want to give it a shot. Okay.
Yeah.
So my next question for you is, what skills do we need to get started with embedded programming?
Yeah.
Like what kind of
So
skills as a beginner?
yeah, so as a beginner, actually the barrier to entry is a lot lower than other stuff. because like I feel like developers today actually take a very roundabout route. Think about this: you are entering college, and you just start learning C programming or C++ programming in your intro to programming course, and then you say you start with web development, which is a totally different thing that has
Correct.
nothing in that has nothing in common with C or C++ that you learned before, or the C++ that you're doing for DSA. Now you're suddenly doing HTML, CSS, JavaScript, learning
Mm.
20 different frameworks, and
Yeah.
breaking your head. In contrast to that, to start with embedded programming, the only thing you need to know is C. Like, if you know C, you can write embedded programs. That's it. Even for beginners, companies like Arduino, they've built simplified programming languages, built on top of C and C++. So even there, right, if you just know one programming language, and one
Mm.
programming language, to what level? Do you know how to take an input? Do you know how to run a loop? Do you know how to print output? That's enough. That's literally it. Even now there are things that make it even easier. The newer boards by companies like Arduino and ESP and Adafruit, they come with a fork of Python. It's called MicroPython. So you can even program in Python if you don't like C. So the entry level is really, really low. You don't need to know a whole lot to get started. Obviously, it goes very deep, but yeah, that's something you can worry about as you pick it up, right? So yeah,
Awesome. So one question that I had was, first of all, C had a very special place in my heart because I did not come with a programming background. I had a physical education elective in my 11th and 12th standard.
yeah,
So the first language that I learned in college was C. So
yeah.
I want to know that the C that the college teaches us in the first semester in the first year, is that is that what is required for the embedded programming, or is it some different kind of C or different?
Yeah, I mean, usually like the microcontrollers that are in the market, like say STM32, they use a version of C known as embedded C. So it's like it's basically C only, but you have some special features like accessing registers in the board directly.
Yeah,
And like in the beginning, it's kind of intimidating, because embedded systems don't have a single entry point. Like, the reason many people are so comfortable with doing DSA is because it's very linear. You know that, okay, yeah, I got to learn C++, I have to learn STL, I have to learn these particular concepts, and yeah, that's it. Or even with web development, you have to start with HTML, CSS, JavaScript. But in embedded, it's a little more fragmented based on the kind of board you start with, or based on the architecture that you start with. You will be looking at different types of C. You'll be looking at different languages. Instead of microcontrollers, if you're working on something like Raspberry Pi or BeagleBone, you will be spending a lot of time configuring Linux. So it's not as unified as these other fields. There is a lot of different stuff. But again, many programming languages by now, and you know that by the time you pick up your third or fourth language, it's only a matter of picking up the differences in syntax. Like,
correct,
learning new
correct.
programming languages is not difficult. So it's just like that. All the basic concepts are same across all of these different things, but there are small differences that you need to pick up as you move from one kind of device to the other kind of device. So yeah,
Okay, got it. So basically, if you are clear with the concepts of programming that happens in the first semester, that
yeah,
our loop runs, what are its statements, what is switch statement, I
yeah.
guess you will be able to navigate embedded C and C using the just basic
Yeah,
resources.
yeah, basically, like in one of the internships that I did with Element 14, my job was to design applications and teach them to like 8th grade and 7th grade kids using hardware, microcontrollers.
Nice, nice.
And these kids, dude, we started with examples like how to blink an LED, how to sound a buzzer, and they built stuff like EVM machines, exercise trackers, a
Okay,
fridge control mechanism, because
nice.
kids were able to do that. And the reason that so many, like, companies like BBC Microbit exist, and they ask kids to start with hardware instead of pure software, is because it's less abstract. Like, you're not dealing with so many abstractions, you're dealing with real world stuff. So
Correct.
yeah, in that sense, it's very, very beginner friendly to get started off.
Okay. And how much time did it take for kids to come up with that EVM machines and like?
It was just a few months. Like, we worked over 3 months, and after the first month, they started coming up with stuff. I wrote it. I mean, I wrote down the various stuff they built in a blog also, and I was blogging as they were building. So yeah, they were building all that, taking advantage of inbuilt sensors, accelerometers, gyroscopes, manipulating data like there's no tomorrow. Later they started using like stuff like Bluetooth in order to control these things with their mobile phones. Somebody built an entire model smart home also.
Oh,
Like,
damn.
it's stuff that you can control with an app. Yeah, they got pretty good pretty fast, and it was honestly pretty shocking, because that's not the idea I went in with. So
Yeah. Like kids these days are pretty intimidating. You can't deny that.
yeah,
Okay. So, moving on to the next question. There's a subject called MPMC in our college. MPMC stands
yeah,
for microprocessor, microcontroller,
yeah,
and it's like mandatory subject for everyone, whatever
yeah,
branch you are in, and whether you are in computers or whether you are in electrical or electronics. So the thing is that in that subject we are taught about 8085 and 8086 microprocessors,
yeah,
and for the microcontroller we are taught about the 8051 microcontroller.
yeah,
And even in the labs we are supposed to do programming on the 8085 and 8086 compilers.
yeah,
We do stuff like add numbers, run loops, sort numbers, find number is a prime or not, stuff like that.
yeah.
So, do you think these kind of education, these kind of lab experiments would help us to become better embedded programmers, or these are just waste of time and the level of embedded programming has gone up way beyond that? It is different.
I mean, in a way, like, it's stuff that you should know, but does it help you really like embedded programming? I think not. I think it's about the worst way to introduce somebody to that topic.
Yeah,
And I don't know how our education system manages to do that with every single subject with the same amount of consistency, right?
yeah,
There, I mean, you work in a language for statistical computing, and you would have taken a statistics course in college, so like the difference between theory and implementation.
yeah, correct.
It's very big. So the problem with the college courses is they don't focus on what you can do. They just focus on how you should do certain things, but without really focusing on what you can do. Obviously there's still a lot of work being done in programming fundamental microcontrollers, but that's nowhere near the level that they're being applied at today. Like, now you have devices like FPGAs, field programmable gate arrays. So these are basically devices where you can program literal sets of hardware into emulating something else. Like, an FPGA is just a board with empty logic gates, and you can configure that in any way you want. So think about it. People have built their own GPUs using FPGAs,
Oh,
and
damn.
it's very relevant to you. But FPGAs are how most of these blockchain mining devices are made. Like, you might have heard that miners in China use devices to mine blocks, Bitcoin and Ethereum, right? So
Yeah.
they have devices like Antminer and all that are like 1,000 times more efficient at mining blockchain than your normal GPU.
Oh,
So like, there's one of those devices. It's called the Antminer. It consumes about 7 times the power of a normal GPU, like about 1,400 watts. But it's literally like 10,000 times faster than an RTX 3090 at mining.
damn.
So those kind of devices are only possible when you can, like, how they do that. They are able to make a piece of hardware that is very very efficient at running one kind of code, and that is the Bitcoin hashing algorithm. So just like Tesla's, right? Tesla's autopilot system. So that is also really really good at one kind of thing, and that is recognizing people and the markers on the road. They use neural networks. So I mean, obviously they use neural networks, and that uses AI and ML, but you got to tune the hardware to that specific thing to do that with the least power consumption in the smallest footprint with the least heat generation possible. So now we're able to do stuff like that. There's also an example of a team that was able to train hardware to design particular kind of antennas to pick up on
Oh,
certain signals. So using a concept known as genetic algorithms. So just
okay.
like how we have DNA, and that DNA, like how kids are produced, and all that DNA mixes up, and there are mutations and all that.
Yes,
So you write code that mutates with each generation, introduces a change in the hardware, and just generation by generation that code becomes more and more optimized towards producing certain kinds of hardware. So
okay.
using hardware to produce hardware. So we've gotten
Okay.
way beyond the days of just using 8051.
8085.
Yeah. Yeah,
Okay.
there's a lot of cool stuff being done in that area, in AMD as well, right? We're
Yeah,
building all kinds of wacky stuff uh, that is in the pipeline.
yeah. See, this is what I understand and what I actually know, that a general laptop, it can do many things. It can do almost anything. But a hardware, you can take it and you can make it extremely optimized for one single task, and that is the power of embedded programming. And
Exactly.
that is just way beyond awesome, man. That is really cool. So, just a second, okay, just a second, Ashutosh. Hari
Yeah.
Krishna, can you open your speaker? Uh, Hari Krishna. Okay, no problem. Let's continue, Ashutosh.
Yeah.
So the next question that I have for you is kind of a subjective, personal question, maybe.
Yeah.
So the question is, what is the one project that you are very proud of, that you have worked on and you are like very happy that yes, I worked on this. Yes, this is my creation.
So I guess that would be my GSOC project. Okay. So
Okay.
the basic problem in this problem statement was very weird. Arduino had this whole bunch of libraries that they wanted to translate. All of them, like the example codes in the library, were written in Arduino's own programming language.
Okay.
It's built on top of C and C++. It just like they've defined some user defined functions and data types, and
Yeah.
they built a language on top of C++ that's easier for people to use. And they wanted those examples to be rewritten in MicroPython. So
Okay.
I was able to write a tool to automate a lot of that process. Like it can just take C++ code and directly translate it into Python. And this was a total proof of concept thing, because nobody was sure, because Python and C++ are very very different languages, right?
Exactly.
Uh,
Exactly.
so so that is how I got into compilers as well. I realized that, damn dude, you can translate literal programming languages into each other. And then I
Yes.
realized that a lot of the tools that developers use, there's this tool called Babel. If you write code in ES6, you can backport the code into ES5 using this thing. So there's a whole class of compilers known as transpilers
Yes.
that can convert one programming language into another programming language. And now you have things like WebAssembly that allow you to write C++ and run it inside a web browser directly. So that GSOC project was probably my best, like my proudest project so far. Since then, I've gone on to try out other things, but that's the starting point. That's what really got me into compilers and compiler development and all that.
Awesome. Like literally changing C++ to microprocessors. That kind of seems impossible to me. I can't even. go out and imagine how would you have lexically parsed and create parse tree. And I don't even want to think about that. And anyone, if anyone has questions from the audience, they can put it in the chat. Maybe I'll ask him.
Yeah,
So
sure.
Yeah, definitely, definitely.
yeah,
Somebody said something, I guess.
Pritish
Yeah.
Pradhan. Okay.
Yeah, hi Ashutosh.
Hello.
So I had a question, like, what's the difference between embedded software coding and coding in an Arduino? Like, we code in an Arduino to control a motor or it, but what's the
Yeah.
difference between embedded software coding?
Yeah, so this is a good question. Basically, you have to realize that boards like Arduino or STM32 breakouts, right? They are what is known as development boards. Like it's like a training ground. Like there are Arduinos with a lot of sensors inbuilt, and the Arduino obviously the base Arduino is a pretty big board that has a lot of holes for pins and all that. So the things like Arduino or ESP32 and all, they are used in industry, but they're used for prototyping. Like say before you build a product, like before say you build an app or you build a website, you first got to build a prototype version that you can show, right? That yeah, this proves that it can work. So Arduino and ESP32 or STM32 or PLC, like all other such boards, they're used for prototyping, Raspberry Pi and all that. Once you decide that, all right, sure, I've decided that I've made this, say, CCTV system, farm monitoring system, or whatever application you can think of. Then from there, it becomes a question of optimization. Then instead of choosing something like Arduino, you might choose the smallest smallest and cheapest AVR chip that is capable of running a program. Instead of using the Arduino, which has a whole lot of things you don't need, you're going to fabricate your own PCB. You are going to optimize for that. And obviously, between the step where you use an Arduino to prove that an idea can work, and between the reaching the point where you release a commercial solution, you might also use embedded C instead of Arduino's own language, because embedded C is a lot more efficient with stuff. You might not make use of some features, and you might fabricate one SoC, like one chip or one PCB that does everything. So that's the basic difference. Starting with Arduino and Raspberry Pi and ESP32 and all, it's like training wheels for building proof of concepts that ultimately lead to the finished product, where your embedded programming comes in. So that's the basic difference.
Cool. I think that answers his question. That was a good question. Correct. Anyone else has any questions for Ashutosh, or should I continue? Okay, I don't see any raised hands. So okay, cool. So Ashutosh, on to the next question. Right.
Yeah.
So okay. So I remember in my first year, a training company came in my college, and they were offering us some 3-day workshop for ARM processors. So
Yeah.
I was not sure what even processors are. Forget ARM processors.
Yeah.
So so the only thing I saw was that they required 3,000 rupees from us for for hardware, and 2,000 rupees for training or something like that.
Yeah.
So, as a new college student who has just gotten into college, I was pretty scared about 5,000 rupees. Now,
Yeah.
like maybe I would have spent 5,000 at least. But that time, as a student in my first year, I was scared of the cost. So, I want to ask you, can you give us some tips as to how to minimize the cost required for starting with embedded programming?
Yeah, so there's a few interesting approaches that you can take here. One is making the most of what you have. Like you have to realize at some point that reading values from sensors is a very small part of embedded programming or of IoT. Like, yeah, sure, you're reading values from sensors. You need to buy some hardware and some sensors, that's fine. Or that's probably not a lot, because if you buy the hardware in the wild, since you don't have to worry about making a profit, the cheapest Arduino runs like around 200 bucks, 250 bucks, and you
Oh,
can get like 10, 15 sensors for like less than 2 3k at most, and you can buy a few at a time and reuse some of them. So again, there are tools like Proteus and all that that allow you to run simulations of hardware. You can simulate an Arduino inside the software. You can simulate sensors inside the software, and you can basically test out your idea inside like a computer before you actually deploy, like buy anything. So that's one approach. Another thing is, if you are interested in sensors like accelerometers, cameras, gyroscopes, temperature sensors, your mobile phone has a whole lot of sensors. And there are apps that you can download that will track all of the sensor readings from your mobile and put them into a CSV file. So like, even when we were working on our idea for the gauntlet thing for Smart India Hackathon to track exercises, the first step would be like, we would take a mobile phone, switch on the app to read all values from all the sensors, strap the phone on our hand, do exercises, movements, and then take those readings and try to run machine learning algorithms on that to extract patterns. So, devices like your phone actually have a whole lot of sensors already in them. So you can take advantage of that to, build prototypes out of, or prove that the software side stuff that you have works. And again, once you buy the hardware, also say you buy an ESP32, it comes inbuilt with Wi-Fi. Now you brought a few sensors to read data. Now you have a whole lot of stuff that you got to learn. You have to learn how to send that data to a cloud or to a like website using get requests or like fetch requests. You have to learn how to process that data. Maybe if you want to build a UI dashboard, you got to learn how to build UIs. If you want to do like say computer vision stuff, OpenCV stuff, you got to learn all that also. So that is one thing. And yeah, obviously, if you have 4 or 5 friends that can each buy like, a different set of sensors or hardware, and you can pool in your efforts. So that is one more way to reduce the cost. Instead of 5 people buying the same sensors and spending 5 times the money, each person can buy 5 different things and share it with other people in order to, like, learn together. So these are some of the ways you can reduce the cost that I can think of. But yeah,
got it.
definitely don't go for overpaid courses if you can avoid them. It's the same situation everywhere, right? We all know about those reverse
Arre,
internships and paid courses where they promise you certificates from 10 companies at once. It's
even now, like we know, paid courses for open source.
yeah, I
Anyway,
mean,
yeah.
yeah,
Anyway, so okay, so the name of the game is Jugaad,
yeah,
and you can work your way through with minimal cost,
yeah.
and test out your hypothesis on software. Almost everything you can test out, and if you're convinced, then go in and buy the stuff, because you
Uh,
have to buy to make
yeah, one more thing you can do is, there are online communities like Element 14 and Hackster.io. So Element 14 and all, they run giveaways. They literally ship you hardware for free. You
Oh,
have to just promise to review the hardware. Like, what they say is that they want reviews of how the product works, and they want reviewers. So you make a deal with them. The deal is just that they'll send you hardware that you can keep forever. All you got to do is you have to use the hardware, test it out, and write a review about how it was. So I got a lot of hardware that way.
damn,
That's it.
man, that's such a great deal, man. Wow, that is awesome.
Yeah.
Wow, like wow, like this is just too good.
Yeah.
Nice. Okay, okay, okay. So, wow. So, okay. Gaurav has asked in the chat that can you repeat the name? of these companies?
Uh, yeah, so one of these companies is Element 14. So these guys are the people who distribute the Raspberry Pi and microbit throughout the world. Others is Hackster.io, and then there's Hackaday or something. There are other sites also. Like basically, right? These this way you can get a whole lot of stuff. I got a Raspberry 4B before it released, like to the general public. Then once Microsoft was running a giveaway, they made
Wow.
these new boards for their Azure IoT platform, right? So the board cost like 9K, but they gave it away for the shipping price of $300. So just
Wow.
because they wanted people to work with that hardware, Nvidia runs that for its own Jetson Nano and other boards. So if you search around, right, you'll get
Yeah.
some really good deals where
Wow.
you can, yeah.
This I don't think anyone could have given this advice to students because man, damn. Wow, I didn't even know that. So wow. Okay. Now comes a very important question. A question that I had got from two things, like quite a lot of students, that you have a lot on your profile, that you have done literally a shit ton of work in your college days.
Yeah.
So the very obvious and general question that comes in people's minds is that how did you manage all of this with your college studies and a decent GPA? You have a 7.5 plus GPA, right?
Yeah, it's around 7.9 or something right now. Yeah.
It's almost 8. So how did you
Yeah.
manage that with college studies?
Like, I guess one of the points is that it was pretty hectic, and I always didn't manage it well. There were a bunch of mess ups.
Yeah.
There was like at least for some competitions, in the salt systems in the Chennai round. I went to Chennai like one day, like 2 days before my internal started, and we caught a bus from Chennai at 8 p.m., reached Bangalore at like 7 a.m., and I just rang up my friend like, dude, you live near the college. Can I come to your house to take a bath? I gotta go write the exams. So, so there were a bunch of close calls, right? The main thing is obviously if you like doing something, managing it becomes easy. And obviously, right, like how college exams are. If somebody is studying for months and months before exams come, then they're sort of not making the best use of their time. So just like
Correct.
so just a week before the exams, you completely pivot away and decide like, damn, dude, I need to start studying now, otherwise I'm going to be in trouble.
Yeah.
So a lot of it was like that. And then there were remote internships, right? All of the work, whether it was GSOC or LFX or with FSF, it was remote. So that allowed me, and like, these people are all very accommodative of my schedule. Like when I started with FSF, they were in Boston time, and when I started, my AMD internship started at the same time within like a gap of a month. So it was like for like about 2 months, from 9 a.m. to 5 p.m. I was working for AMD, and from 8:30 p.m. to 3 a.m. in the night I was working for FSF. So
Yeah.
that was like that was pretty intense. Other than that,
Wow.
hackathons and all that are usually during the weekends.
Yeah.
So I mean, if your idea of fun is to stay awake for 2 days straight and write code instead of going and watching a movie, then sure, you can do 10 hackathons in a year without it disrupting anything.
Wow.
Yeah.
That is really cool, man. And to think about taking a bath is something so that was hilarious.
uh,
Okay. So the follow-up question to this is, you did a lot of projects, you did a lot of hackathons. So does that help in your college projects? Does that help in getting a good rapport with your professors?
like yes and also no. Like yes, because the professors that recognize the value of this stuff, they generally support you. But no, because some professors are like, you're submitting your assignment late and I don't give a shit whether somebody in your family died or you were busy with a competition. It literally doesn't matter. So some professors can be very apathetic that way. But yeah, one thing that it does help with is, sometimes, right, if work that you've done with hackathons lines up with your college's demand for a mini project or something, you can just submit the hackathon project as a mini project. And I recommend this also. Like, people always talk about hackathon payoffs, like, what happens if I don't win a hackathon? I just spent a whole lot of effort for nothing. Well, you could obviously continue your idea, open source it, and now you have a project to put on your resume, which you didn't
Definitely.
have before. And obviously, in such hackathons, right, if you know how to network, like, give your CV to a bunch of people or connect with people on LinkedIn, and later reach out to them like, hi, I met you during this hackathon. Are you like looking for any interns right now? So if you know how to play your cards, you'll always get something out of a hackathon. And it
Yeah.
becomes difficult to deny its value as this thing. And you worked in a fellowship with a company that specializes in hackathons. So I guess you know
Yeah.
quite quite a bit about this topic.
Yeah. So Ravi Teja has written something like, um, yeah, definitely. What do you think, Ashutosh, about what Ravi Teja has written?
How cool is it to directly program in assembly? And so again, just like the Aam Janta, I don't know assembly very well. I mean, obviously I can recognize assembly and understand what it does, but the thing is, thank compilers for not having to write assembly any longer. For any code longer than say 50 lines or 60 lines or 100 lines at the most, it is literally impossible to beat the compiler in terms of optimization. Like, no matter
Yeah.
how hard you try as a human being, you can't beat the compiler. There's a talk also from a CPP conference, like, don't try to outsmart the compiler. So uh,
Okay.
so yeah, like 9 out of 10 times you can 99 out of 100 times you can optimize without having to drop down to assembly. That's the thing. So yeah, try to avoid
So,
writing assembly. We don't enjoy it anymore than the general public does.
yeah. So, you are a college, you are a student of which college? Can you just tell us again?
So it's this state college. I mean, it's a tier three college called Dayanand Sagar College of
Yeah.
Engineering. If you haven't heard of it, I hadn't heard of it before I started there either. So yeah, I mean, like, I'm an example of the college not really mattering. And I'd also like to add that in all of, yeah, go ahead. Do you have a
So,
question?
yeah, I was about to say that your college is definitely not tier one. We can call it tier two or three.
Yeah.
So, I want you to tell all these people that are here that it does not matter which college you are from, actually, now, at least now, and how you actually got a chance to intern at AMD. I mean,
Yeah.
sorry, entire job at AMD.
Yeah, so, like, the good thing about computer science is it's very meritocratic. Like, if you're good at your job, right, at some point people are going to really ignore which college you're from or this thing. So in all of the hackathons, competitions, internships that I've ever attended, not once have I felt discriminated against.
Correct.
The whole thing about tier one colleges is very much an Indian uncle auntie thing where they are the only people that care. So it's like, think about it, dude. You have open all of this wonderful open source software, especially in compilers, right?
Right.
Compiler engineering is literally like, you contribute a few patches to LLVM and you can get a job at a compiler company, which includes AMD, Intel, Nvidia, ARM, Qualcomm, IBM, etc. So that
Yeah.
is literally the most direct way of getting a job possible. Show us that you can do the job, and
Yeah.
we'll take you in. Like my interview did not have any DSA questions or any typical competitive programming questions or why this company questions. I was just literally asked about compilers and Linux. I answered that and I got the job. So, like, yeah, yeah, don't like, at some point you have to realize that you're victimizing yourself. Like,
Exactly. Correct.
how long are you gonna be stuck on the same point that, dude, Jay nahi hua, kya hua? Like,
Right.
sh- yeah, if you feel like you're a victim, that's what you'll become. So you gotta move past that. There's a whole
Exactly.
lot of stuff you can do from there.
And that is, I'm not sure. Maybe your college tier matters in, I guess, civil engineering or mechanical engineering because the jobs are less. But if you are a computer science student, your GitHub, your LinkedIn, that is enough to get you a job at any place in this world. And I don't know why people would say कि college खराब है इसलिए company में नहीं हुआ. That's bullshit. It
Yeah.
doesn't work that way.
I mean, dude, my
So
interview was like after the interview was over, when they were rolling out an offer letter, they're like, which state is your college in? Are you a student? Are you doing BTech or MTech? So till that point, they had
nice,
they like
nice.
forget asking about my GPA or college. They didn't even know about my student status properly.
Wow.
So yeah, they literally do not care. Like, please move past that. You're just holding yourself back if you think that way.
Correct, correct, correct. So I have a few more questions, but let's move on to the questions that are received from the Triple ID Janta.
Yeah.
One is, should we use MATLAB in 2021? Uh, I don't think that. Okay. Do you have any thoughts on that?
I mean, I think if you are in an industry that needs MATLAB, sure, but dude, there's languages like R and Julia and Python that,
Exactly.
dude,
R
don't
is for a
use a
why.
don't use a programming language that needs you to buy a license, man. Come on.
Exactly. Come on.
Come on. Yeah.
And okay, so the next question is how and where to start contributing to open source. Okay, okay, wait.
Yeah.
I'll answer that in a later discussion. What you can tell us is that how and where to start contributing to open source in the hardware space.
In the hardware space, yes. One good way is trying to for Arduino or for other microcontrollers, you can try contributing a library of your own, a library that optimizes this thing. So the good advantage of this approach is if you write a library, you don't have to worry about the rest of the tool chain. Like, if you make mistakes, it won't propagate to the rest of your system. So try, like, say, contributing a library to Arduino. Other than that, join these open source hardware communities that I mentioned earlier, like Element 14, Hackster, Hackaday, and all that, or even the Raspberry Pi forums. You can contribute design docs. You can design PCBs that interface with the boards. You can write documentation for them. That's a whole lot of stuff you can do. In other than that, for compilers already, I think I've specified either pick up and contribute to one of the compilers. It's as direct as that. So yeah, there is a learning curve to both of these things, but it's a lot more straightforward. Like,
But it's
if
well
you're,
worth it.
yeah, it's well worth it. It's well worth it. It'll get. It's like, it's the one thing that you can directly point out in a job interview and change the whole thing in your favor. It's like that.
It's huge. That means it's huge, right? Like
Yeah. Yep.
contributing a library. Great, great, great.
Yes.
So okay. So the next question is a pretty interesting question that
Yeah.
that I would like to put forward. So, dear Ashutosh,
Yeah.
you currently work at AMD.
Yeah.
Suppose you get a slightly better offer from Nvidia, would you jump ships and leave AMD?
Currently, the answer to this is no, and I'll explain why. So obviously, AMD was one of my dream companies, but I'd be lying if I said it was my only dream company. We all applied to a lot of companies, and
Yeah,
I
definitely.
like I did apply to Nvidia and like Intel also during the application process. But once I got in, right, the main thing was. Open source is largely responsible for getting me my job, and
Correct.
whole lot of Nvidia stuff is not open source. Like AMD's whole GPU driver stack, their whole compiler, and a whole lot of their other tooling, like even the new DLSS technology that they introduced a few days back, all of it is open source. So considering that open source got me where I am today, I'd rather work in a company that works on open source rather than working on a company that works in closed stuff. And also from a career point of view, right, if I'm in AMD and say I choose to move on to a mainline tech company or something, because it's open source, so that makes it a whole lot easier. So yeah, I'd rather stick to AMD for now.
Right.
And yeah, it doesn't hurt that they're doing the best out of the three. So
Yeah. Yeah, yeah.
yeah,
Good
that's
point. So regarding what you said to the earlier question, contributing in open source in the hardware space, you told us about the importance of communities. So I wanted to have a
yeah.
discussion with you about how should students go about joining or even forming communities, and also maybe we can talk about some of the maybe scam communities that are pretty
Yes,
popular right now with
yes,
their own YouTube channels and stuff.
yes.
So maybe you can help us, the students, how to identify such communities.
Yeah, so like basically the first thing about communities is, I think the one very basic thing that we don't know as a group is how to ask good questions, well-researched questions. If you are ever getting introduced to a community, say you're the maintainer of an open source project, you've
Yeah.
been working on it for the last 5 years, and somebody joins your Slack channel and asks, "Can I know what this software does?" So you know, so you
Yeah.
know what that's gonna be like. So if you ever get stuck, if you ever have bugs, try to put in your own effort and do your own research before asking questions. This alone thing is going to make a big difference. And in terms of communities, right? There are certain communities that will try to sell you stuff, namely courses and all other stuff. And we've been having a very big problem with this kind of stuff, even on LinkedIn, on YouTube.
Yeah.
So any community that's just like any community that doesn't have a very clear product, like what are they
Correct.
selling, I mean what
If the
what are they
building,
building,
yes.
like yeah, what are they building, like when it's not clear, right, what are they building, then it's very probable that you are the product and you are the person that is getting sold stuff. So please be like use your judgment in when you join communities, when you see that like the one hallmark of most open source communities I've seen is people are very very humble. Like
Mm-hmm.
you can talk to the maintainer of the project and they'll still tell like that's an interesting idea, or I hadn't thought of that before. Even if they have, like, they're really really polite, they're polite almost to the point that they won't point out even if you're making mistakes. But if you see any community where there's a cult around the founder, that array this bhaiya is OP, or this bhaiya
Marriage.
knows everything, or this person knows everything, that's a very big red flag. Because proper communities, they actively discourage that kind of behavior. Like they don't want you to idolize people, because nobody is infallible, and the whole thing about open source is that nobody is irreplaceable.
Correct.
So just just be wary of these things.
Just one more point, if I would add to that, and you can also expand on that if you want. all the banners
Yeah.
that you see behind these communities. Suppose I open a community tomorrow and I put the banner of Google just because I am like I was once a Google DSC. So try to like gauge why this person has a banner of Google behind it. Is this course offered by Google, or is there some other affiliation that I'm not aware of? And when you are aware of that affiliation, you can judge for yourself whether it is trustworthy or credible enough affiliation, and then move on ahead. Okay.
Yeah, I mean, I think in this contributions and code, they speak very loudly. Like,
Yeah.
there is one community, I think I'm not even afraid of naming it at this point. Cloud Native Compute Foundation is one of the largest groups of cloud microservices and all in the world.
Yeah.
Basically, CNCF is like the Google of the cloud microservice space. It's huge. It's worth trillions of dollars.
Correct.
But they have like recently there's been a student community launched by some persons, and the person who runs the community has only two commits to CNCF, and both of them are documentation fixes, and both of those PRs have not been merged yet. So
Oh, oh, God.
okay. So like, obviously if a person is only talking about communities and they don't have the code and contribution to back it up, again, that's a very big red flag. Please don't follow cults of personality and all that just because I am telling you something is right, or Rahul is telling you something is right. That doesn't make it correct. Use your common sense. Don't fall for a cult of any kind. That's very important.
So that was a great discussion that we had. So next, moving on to the like, what can I say, meat wala question, masale wala question. So the question basically is asking, like, this English is not critical, so I'm rephrasing it. Like, how is the job market for embedded programmers? And I have heard that there are several different positions such as embedded software engineer and embedded hardware engineer. And can you reveal the salaries of your seniors at AMD? This is
Uh, all right, sure. This is a good question. Obviously, this is an important question because at the
definitely
end of the day, you gotta pay the bills, man. Like
correct. Correct.
that's necessary. So embedded salaries, they start out like maybe a little bit lower than your typical what do you call it,
SD salary.
SD salaries, but they ramp up pretty quickly. There is a reason for this. That is that the learning curve is very, very steep. Like the average SD at least has some idea of what they're supposed to do in their job, okay? But the embedded developer, because of all the hardware and all of the components and everything that's required, they're very far away from being at a point where they're hireable. So, but
Correct.
within a few years, you can get to a very high salary. And in AMD, right, in the whole compiler space, silicon design space, the salaries are very comparable to SDs, maybe even higher in some cases. Like, I think my seniors in AMD, like say the MTS engineers, member of technical staff, that's like after two promotions, what is known as an SDE3 in a software company. So their base compensation is like 33, 36 lakhs per year. And there's stocks
Ooh,
on top of that. So, and
AMD
again, you have to
stocks.
realize that yeah, AMD stocks. So AMD stock was basically $1 or $2 in 2015, and it's around $80 now. So if you had
Yeah,
1,000 stocks also in 2015, that's worth
80x.
800,000. Yeah,
Yes,
80x that now. So, and these companies, right? You have to realize that. Yes, there are lesser compiler and kernel developers in the market than SDs. But the thing is, because lesser people are in this space, your job is very, very secure. Like, there is literally no chance of you going jobless. Ever since even when I started interning at AMD, I've been getting calls from Qualcomm and Nvidia and
Oh,
I'm like every other week because because compiler developers are a rare resource. Like there's probably a few hundred compiler engineers in India, and that's it. And in AMD also, our compiler team consists of 35 people, and those 35 people write basically all of the drivers and optimizations for all of AMD's chips. So you can imagine like how important those engineers are. So if you do decide to go down this route, and just remember that small companies typically don't need compiler engineers. It's all the big companies, so it's a bit high risk high reward, I'd say. But there is one good thing, that compiler engineering is largely done in C++, and embedded is also done in C and C++. So you can always work at a regular company as a C++ developer, if you or you can work in a game company, or even like in cyber security, dude. Some of the tools that we use, right, are tools that are used by cybersecurity analysts in malware analysis. Like
yeah.
we use one software made by the NSA, literally
Oh,
the NSA
yeah.
that of USA. It's called Ghidra. So we use it for reverse engineering our opponent companies' compilers and all that. So even for it overlaps over there also. Basically, it's like, if you say what scope does compiler engineering or embedded have, you have to realize they're only subsets of a very big market, that is low level programming. It's
Yeah.
like, asking how much does a React JS developer make, or how many React JS jobs are there. That's because React JS is just one framework in the entirety of web programming, which is a really big field.
Yeah.
So that's what I'd say, right? Look at the other side of the curtain for once. What goes underneath your computer before you interact with it, right? That's a huge, huge market. There are a lot of jobs, and it's only getting bigger. That's
One message that I would like to give all the students here that are listening and would listen in the future is that don't be afraid to niche down. Like I have had friends who were the kind of kids, who took out their robots and see what the chip was in the inside of that, saw how it runs and stuff like that. And when they came to college, they wanted to explore further how all the electronic stuff works, how all the sensors work, but they were kind of told by everyone that there are no jobs in this and there are very few jobs and you have to learn I mean JavaScript and all. So it's kind of killing a very happy dream.
yeah,
And
like
exactly, so as
yeah.
Ashutosh told, see, the jobs are less but the people capable of doing that are even lesser. So if you can actually do something good, you would never run out of a job in this low level programming. And this
I
is
mean, we all grew up watching movies about people hacking into government servers, and we all
correct.
thought of hacking into Facebook or hacking into something with
NASA.
green tech, NASA, and green text appearing, or reading stories about Aaron Schwartz and Edward Snowden and how they hacked into NSA and all that. I don't know
Yeah,
what happens once we start college. We'll be like, yeah, dude, I'm just gonna abandon all these dreams and make websites. So there's nothing
exactly.
wrong with making websites, but there is a whole
Like
lot more stuff
if
you can
if
do.
if you enjoy making websites, then fine, then great. But don't let go of your cybersecurity dreams, of your electronics hardware stuff dreams, just because someone told you, hey, इसमें job नहीं क्या करेगा.
Yeah,
It doesn't work that way. Like it's a very cliche line from Three Idiots, but it is true. Let me tell you, like
yeah,
रणछोड़ दास said ना कि excellence के पीछे भागो कामयाबी खुद पीछे आएगी. That is true, man. That is as true as Bollywood movies can get.
yep.
So
There's
yeah.
one question I think from the audience.
Okay, okay, okay. Sorry.
The I think no, it's a direct message. The question is, how does a typical day look like at AMD?
Okay, okay. Good.
This is an interesting question, because it's sort of different. Like basically, you have to think that 40-50%, like 60% of my time goes in stuff like reading research papers and trying out approaches that have never been tried before. Typically we start like AMD doesn't have fixed work timings. The only time you have to be online is between 12 p.m. and 5 p.m. because you have to hold meetings at a common time. So most of the days I start like around 10 a.m. like nice and easy, and I read papers. I think about the bugs that have been assigned to me. I read existing literature. I work on optimizations. Then we write a lot of docs before writing any code, because it's not just about solving the bug. It's just about solving the problem in the most efficient manner possible. Like, yeah, you made a fix, but is that fix the best way that this thing could be fixed? So we go over our own patches and optimizations a whole lot, to see if there are newer ways that can be done. Also, we do a lot of reverse analysis stuff. We also do a lot of optimizations. We try to implement new features. We take applications like right now. One of the applications I'm trying to optimize for is something related to quantum chemistry. So I'm reading papers on quantum chemistry and that application these days to see like where I can optimize stuff. So every week or every other week, you might find yourself dipping your toes into new and very very different fields. And I think that's what makes it very fulfilling and different from an SDE job. There are no clients, there are no customers that you have to answer to. You just have your own compiler, and the focus is always on correctness rather than speed. So if something can't be done in this release, it will be done in the next release. Things are never done in a hurry. So yeah, that's what a day looks like at AMD.
So, Bhaiya, just one more question for you, Ashutosh.
Yeah.
Like it's in the chats, you can.
Yeah, yeah. I am a CSE student, and the students different software. What motivated you and others to motivate stand up and go for software come electronics? So, dude, in this again, I'd say that not everything is a carefully calculated decision. Sometimes it's just to see what you like. And I told you, right? Like I was in a team that used to build drones, and like for the first 2 years of my CSE degree, I barely did any programming. I was I was running simulation softwares for aircraft. I was doing laser cutting. I was polishing wood. I was cutting aluminium and doing all kinds of random stuff until I jumped into electronics. So basically, my whole idea was let me try out different things so that I can be sure that I really like this. I tried out. I took some courses for ML just like everyone else. I absolutely hated web development, so I didn't go in that direction. But once I started with electronics, I was like, I want to explore this space further. And then one step above electronics, which is the lowest levels of the computer, that is compilers and kernels. So it was not a very calculated decision, but I knew that I liked it, and it was what I wanted to do. One more advantage in this field is that your work, whatever your job you're applying for, that's exactly what you will get. With a generic SDE job, right,
Yes.
there's always a risk that you are interested in something else and you'll get put in some other team. But I did not apply for an SDE job. I applied as a compiler engineer. Compilers were what I expected to work on, and that's what I'm working on. So that surety and that thing about working on cutting edge hardware stuff is what motivated me. I never really thought that everyone is doing this and I should do the same thing, because somehow that didn't seem like a very good idea, right? Like if yeah.
So, like, you basically told this guy that you explored your stuff and you found something. So that
Yeah.
is also typically what happened with me. As you told that every one of us grew watching hacking done on NASA and like US government. So in my first year, I did some yeah, network security stuff. I formed the Infotech Society of my college, and after that, I gave some lots of cybersecurity awareness lectures. Then in my second year, I mean fourth semester actually, I started doing competitive programming. Figured out that it was definitely not for me. And in my fifth semester, I shifted to doing data science. There I learned about R. I started contributing to R when GSOC happened. I worked with R, and after GSOC, I started doing a bit of Flutter development for mobile. Thought that it is cool, but I couldn't particularly enjoy it. And then, just by sheer chance, I applied to a blockchain fellowship, and I fell in love with it. So right now, my job profile is a blockchain engineer, smart contract developer, and what can I tell you, man? Just don't be afraid of discovering what you actually like, and if you actually find something that you
Yeah,
like, however niche that is, however small market for that is, you will be paid well. Just
I
trust
mean,
me.
I mean, basically, I can and Rahul can basically tell you that we knew what we were doing all along, and we had everything figured out when we were 17 years old, and that's how we got we are today. And you would have believed us because that's the only point of reference you have. The real answer is that a lot of these things are like after the fact, man. Like we were as clueless as you guys are. We just tried different things until we found something we liked. So don't be afraid of exploring. That's the one thing I'd say, dude. It's really important. It's like that guy who said on LinkedIn, right? Like basically they gathered 100 people in a room and they told toss a coin, and every time you get heads, those people stay, and those people who get tails, they should leave the room. So from 100 it reduced to 70, then 50, then 40. In the end, only one girl was left that tossed head 14 times. And later the media came and asked that girl, what is the secret to your success? So, sometimes it's very, very random about how these
Uh,
things happen. Don't look for this is why I tell, like, don't look for roadmaps and all that. There is no roadmap. The only roadmap is the path you eventually end up taking. That's it.
yeah. The one thing that I'd like to add to that is when you are exploring. Suppose you are exploring the field of data science. So exploring the time period, give it your everything. Give it everything. Do the courses, do open source, do all the YouTube videos you can find, do all the coding. Suppose you're doing cybersecurity, give it your everything. Don't hold back there, okay? And after giving it your all, if you realize that you enjoyed the ride, enjoyed it, fine, continue with it. And if you did not, trust me, you wouldn't want to do that for the rest of your 40 years of professional life. Okay. So okay, Ashutosh, if you are not very much spent for time, can you just answer one more question, or
Yeah,
should
sure, sure. Go ahead, go ahead. No issues.
okay, okay. What can I tell you? I have a very good friend, a childhood friend. You know, concept of best friends.
Yeah,
So we were very good friends in school, and he went to do mechanical engineering at NIT Durgapur. Yeah.
yeah,
So he told me something that although the guys from NIT Durgapur are at Mercedes, are at are at even BMW and the good leading car manufacturers, but he said something that all the innovation, all the thinking part, all the cutting edge technology that is being worked on, it's being worked on in Germany. In India, it is just the implementation and kind of the back office of these mechanical engineering giants. So, is that the case with the AMD or the low level programming in general?
I think this is less of a problem in terms of the hardware, the semiconductor companies, as you call it, or the low level companies than in software. Like, even Google India has this problem. Most of the developers in Google India, they work on Google Home, and one of the person's job profile was literally that they work on the sports section of Google Home. So a lot of the important all of the search teams and Google Brain and research are based in Mountain View. But the
Correct.
thing with AMD is Ryzen was developed in Hyderabad. Like
Oh, damn.
AMD's Ryzen processor, the OG Ryzen was developed in Hyderabad by an Indian engineer who has been born and brought up in India. The lead of that team, her name is Anusuya Bhaumik. She is the manager of one of my friends who also works at AMD. And the entire compiler team of AMD is in India. And this is true for other companies as well. Even for Intel and all, the entire security and threat team, they sit in India. So for semiconductors industry, at least this is not true. They are going to work on the most cutting edge stuff in India. Yes, the only part that is outsourced is the manufacturing stuff for obvious reasons, which is with China and to some extent in USA right now. But all of the silicon design, testing, or validation or performance improvements, it's all done right here in India. And it has been done in India for a while. And most of AMD has like 2,500 of AMD's 12,000 engineers are in India. So that's a pretty big number.
That was really nice to hear, and I felt glad that that is not the case with semiconductor companies. So,
Yeah.
one last question is that you mentioned in your day as a AMD engineer that you read research papers, you find out, you literally formulate strategies to build stuff. So I wanted to ask that it is generally a conception in preconception in almost everyone's mind that this kind of job where you have to actually formulate stuff and come up with new designs. This kind of stuff is reserved for people with MS, MTech, PhDs, and stuff like that. So would you like to tell us that for working at AMD on higher levels, is an MTech or MS or PhD necessary or optional or not required?
Uh, uh, I think like as of now, they're hiring teams in everything from silicon design to system software to the DevOps team. Everything has only a BTech is compulsory, and by that they mean it because they will review. And the good thing about AMD is that if you apply for a job, you can directly mail the HR, and 9 out of 10 times you will get a response. And again, this is a problem due to a shortage of people. Like AMD would probably prefer to hire MTech students, I don't know. But the real thing is that a whole lot of this is application based. Like it's a skill that you have to learn. So a second degree doesn't necessarily make you better. Obviously, there are teams where only PhDs are hired and all that. But that also, like AMD has arrangements like where you can work as a co-op, like you work for AMD part-time and finish your degree full-time. So a lot of the people in my team, they finished their degrees from, like they did a master's from IIIT Bangalore or BITS Pilani under their work WILP scheme while being engineers at AMD.
Oh,
So it's not true because as I mentioned, there's such a big shortage of like engineers for these jobs, right? That is that they'll literally take anybody who has the skill, even if they are like they have only one degree.
yes. So, Ashutosh, that was the end of my questions. And seeing that there are no questions from the audience itself, I would like you to wrap up this session with one final message that you want to give the audience, the students, the first, second years, even third years in their career. So,
Yeah, so the final message is don't be afraid of exploring, and not everything that is gold, not everything that is gold glitters. It's the reverse of not all that glitters is gold. That means just because something doesn't seem very fancy doesn't mean that very cool stuff is not going on underneath the hood. Like especially with compilers, right? Some of the things that they do seem very very like old fashioned compared to the stuff that goes on today. Like most of the compiler development still happens through mailing lists, as in you have to mail the developers with patches instead of using GitHub. So in some ways you feel like okay, dude, or you work on languages like Fortran that are like 50 years old. But just because once you remove that layer from top, like it's just a compiler, then you begin seeing all of the mind-blowing cutting edge work that is there. And whether it's stuff like blockchain, or whether it's even hyped up stuff like AIML, go beyond the hype. Just dig in and see what it really stands for, and see the field for yourself. See it with your own eyes. Don't take anyone's word for it. Explore, and obviously reach out to, don't be afraid of reaching out to people, network with people, and yeah, dude, enjoy engineering. You're here, you're attending this session. That means you're already pretty interested in what you do. So make the most of it. That's it.
Yeah, so that was a pretty cool message, Ashutosh. And I think, yeah, that 4 years is a lot of time to explain a lot of domains. And even if you did not find what you love, what you like, what you would want to do at the end of 4 years, that that itself would tell you that what are the things that you're not comfortable doing, what are the things that you do not have to look to. So don't be afraid of exploring, and whatever you do it with full force. And yeah, that was it, man. That was pretty cool session with you, man. Thanks for coming.
Thanks. Thanks for organizing this. I mean, if I was in first year and I had my seniors helping out like this, it would be a big help. But yeah, it's like we walked in clueless. Hopefully, you
Same.
guys won't. Yeah,
So yeah, thank you, man. Okay, hope to see you, keep on seeing you. And
yeah.
if you want to give these students some social media handle where you are active, where they can message you in the chat
Yeah,
message.
sure. You could reach out to me on LinkedIn. I guess I'll put a link to my profile in the chat. You could use that, and you can get it from Rahul also, I guess,
Yeah,
if that's needed. So LinkedIn is currently the social media I use the most. Other than that, I guess there's my GitHub, where you can see the stuff I've done in the past. You'll find a link to that also on my LinkedIn profile. I'll leave a link to that as well. Uh, and yeah, these two should be good for a starting point. If you ever need help, just message me and I'll respond.
yeah. So okay, man. Thank you. So yeah, that was great.
Thank you.
Yeah.
Yeah,
Okay. Okay. See
yeah.
ya. Bye bye.
All right, man. Bye, bye, bye. Bye, guys.